Welcome to Study Loop.
We need to find the speed of the box after it's fallen 2.5 meters. So we can draw this out. We have our cylinder, then we have our pulley, and the string goes from the cylinder to the pulley, and then a mass hangs. This will be the box, this will be pulley, and this will be cylinder. At this point, we can find the mass of this. We can write down our givens. So the mass of the cylinder, 5 kilograms. Radius of the cylinder, 40 centimeters or 0.4 meters. Mass of the box, 3 kilograms. The height, 2.5 meters. We also have the mass of the pulley, 2 kilograms. And the radius of the pulley, 27 meters or 0.2 meters. We can just immediately convert. So we have energy initial equals energy final. We're trying to find the velocity of the box after it has fallen 2.5 meters. So we have energy initial equals energy final, or GPE, gravitational potential energy, is going to equal kinetic energy trans plus kinetic energy rotational. This would be of the cylinder, and then kinetic energy rotational of the pulley. And at this point, we can then try to solve for this. So we have mass of the box times gravity times height. This can equal 1/2 times the mass of the box times the velocity squared plus 1/2 the moment of inertia of the cylinder times the angular velocity of the cylinder squared plus 1/2 times the moment of inertia of the pulley, the angular velocity of the pulley squared. At this point, we know that the moment of inertia of the pulley, because it's a uniform disk, it's going to be 1/2 mass of the pulley, radius of the pulley squared. For the cylinder, it's going to be the exact same thing, 1/2 times the mass of the cylinder, radius of the cylinder squared. And then we know that the angular velocity of the pulley is going to be the linear velocity divided by the radius of the pulley, and the angular velocity of the cylinder will be equal to the linear velocity divided by the radius of the cylinder. At this point, we can substitute all of these values. So we have m sub b gh equals 1/2 mbv squared plus 1/2 times 1/2 mcrc squared. And then this would be v/rc squared plus 1/2 times 1/2 mass of the pulley, radius of the pulley. And then times v/rp squared. At this point, mbgh, we can simplify and say half mbv squared plus 1/4 mcv squared plus 1/4 mpv squared. So we know that v is going to equal 4 mbgh all divided by 2 times the mass of the box plus the mass of the cylinder plus the mass of the pulley. Quantity to the 1/2 power. And at this point, we can solve. So 4, 3, 9.8, 2.5, and then 2 times 3 plus 5 plus 2, all to the 1/2 power. And this is going to be 4.755 meters per second. This will be our answer. This will be the linear velocity of the box after it has fell 2.5 meters. And that's the end of the solution. Thank you for watching.